and welcome to this video that will talk about computing the derivative with the power rule. Okay, just a quick review on what the derivative is. The derivative is a function that computes the slope of a given function. Okay, so if I have some function called f of x, and I make the derivative of that function, it would be known as f prime at x, or read the derivative of f at x. And this function here will tell you the slope of this function here. Okay, so they are related, so they have similar notations. They both have an f in it, but they're not the same. This is read f prime, or the derivative of f of x. Okay, so to be able to do this for a function that you have to follow what we're going to call the power rule. There are several methods for computing the derivative of functions. The power rule is one of the most simplest forms of it, and it works on functions of this form, which is y equals ax to the n. So if you notice here, it has a variable base, it'll have a real number coefficient, and it'll have a real number exponent. Now keep in mind, this is only seems like it's one term here. I could have multiple terms that are of that form, and I would just repeat the process over and over. So what does it say here? If we have y, how do we go to y prime, also known as the derivative of y? So it looks like we are going to multiply a times n, which in our given, you notice, is multiplying the coefficient by the exponent. We're going to keep the base the same. The base is x, it's still x, and then we're going to subtract 1 from the given exponent. Okay? So it's a pretty easy rule to repeat. It has some nuances when you get into the examples, and hopefully I will be able to show that. So let's take a look at some examples now. So again, I have the power rule at the top, okay, which given y, how do we get y prime? And I have some examples here. Number 1, g of x equals negative 5x to the fourth. Now, what I'm going to write in blue is superfluous. It's something that you can do in your head, but I'm going to, in fact, write it in this video so it makes the basic points of how to use this formula. Okay, what I write in red is something that you could probably go right to unless your teacher asks you to show more work. Okay, so for us in number 1 where it says g of x equals negative 5x to the fourth, I'll be computing g prime at x, and if you notice, I will multiply the coefficient times the exponent, which will give me negative 5 times 4. Then I will keep the base the same, which it says here. The base is x, it's still x. And then I'm going to subtract 1 from the exponent, so I'll do 4 minus 1. Now some of that can be done mentally, so what we have here in red, if I just redo the problem quickly, the derivative of g of x, read g prime of x, can be done by doing negative 5 times 4, coefficient times exponent, which is negative 20, keeping the base, and reducing the exponent by 1 from 4 to 3. And this would, in fact, be an appropriate answer unless your teacher asks you to show more work. Okay, and as I said, in example 2, if we have multiple terms of the form ax to the n, we just repeat the process. And hopefully you were going to see here a few small nuances in this problem that will be helpful to you. Okay? So again, in blue, you don't have to exactly do what I'm doing. You can do it in your head mentally. Okay? And the first thing I'm going to do is rewrite the expression for each term so that it is ax to the n very explicitly. So here we have an ax to the n, here we have an ax to the n, and then here we have an ax, well, and to the n is going to be a 1, so it's x to the first. Now in this last term, it looks like we just have the a, which in this case is 9, but it would be x to the 0. because we know that x to the 0 is 1, so I've just put in a factor of 1, which doesn't change the problem at all. Okay, so now I've just rewritten the problem so that it's more explicit, where we have our ax to the n form. Okay, notice it is not y prime, it is still y. I've not done the derivative, I've just set up to do the derivative. So I'll stay in blue for some superfluous work that can be done mentally. Okay, which to do y prime, we will do coefficient times exponent times x to the exponent minus 1. Okay? Oh, I made a little mistake here while I was saying x to the n. Obviously, this was 3x squared. So continuing on, we are going to get coefficient times exponent with the same base of x, and then reduce the exponent by 1. And then in the next term, we're going to get coefficient times exponent, write the base of x, and then reduce the base, the exponent by 1. And then in the next term, which I just got to pull down a little bit here because I'm running out of space, we're going to do the coefficient times the exponent, which you notice here is 0, and that's going to be a very special case of the derivative. Okay? And then I'm going to write the base and subtract 1 from the exponent. Okay? Now, there's things I could have done mentally, again, done a little more work than I really needed to. So y prime, again, if you're looking from here to here, okay, I would be getting the same answer as from here to here. But I'll try and get you to have an understanding of how to go from here to here just easily, okay, without doing all the extra writing and work. So we've got that the coefficient, okay, times the exponent there. We're going to do 1/3 of 3, which is 1. So I don't have to write that as the new coefficient. X to the subtract 1 from the exponent. Then we've got plus -3 times 2, which is just going to be -6, coefficient times exponent again. X to the reduce this exponent by 1, so it becomes a 1. I don't have to write it. Okay? And then we've got, in the next term, coefficient times exponent is going to give us 2. And then we also see that if I write the base of x and reduce the exponent, I get x to the 0. So I don't even need that because that is just going to be equal to 1. Okay? And in the next term, here, when I do coefficient times exponent, I get 0. Oh, excuse me. 0 x to the -1, which 0 times anything is 0. So you'll notice here I've got, again, 1/3 x cubed becomes x squared. -3x squared becomes 6x negative. And 2x just becomes 2. And then the 9 becomes 0. Okay, we'll talk more philosophically about the derivative another time. I'm just trying to mechanically show you the power rule here. Okay? So now in this example, number 3, you see you have some variables in the denominator. Well, you have to remember your negative exponent rule. Okay? You really should be taking time to write this red line that I am writing here. Okay, so I'm kind of going to go red to blue to red again. Okay? So we realize that x to the 5th in the denominator is equal to 4x to the -5th in the numerator, minus 3x to the 2nd. Again, your negative exponent rule means you could change it from numerator to denominator, but you have changed the sign. So it went from negative to positive, and this one went from positive to negative. Now these are of the form ax to the n. So I can do the power rule because it's written for things of the form ax to the n. Okay, so I'm going to write again in blue here for part that you could do mentally. And again, what I did in red there was not the derivative. It was just resetting the original problem. So now I'm doing the derivative. So you could do coefficient times exponent, which is 4 times -5, x to the reduce the exponent by 1. Extend the page here. Okay, plus coefficient times exponent, which is -3 times 2. Write the base and reduce the exponent by 1. Now, again, like I said, you could have gone right from this line, which was necessary in red to get a good look at the proper form, to f prime by doing 4 times -5 is -20, x to the Dramatic pause. Be careful. When you reduce -5, it'll become -6. Then we've got minus 3 times 2 is 6x to the first, which we don't have to write. Okay? So, again, these final things in red are my answer. Okay? Just notice here there were two problems that the first line I did wasn't really the derivative. Okay, it was just rewriting the problem. Now this first one that I just underlined, you don't really have to do that again because like I said, there's some things there that can be done mentally. This one here where you're resetting these denominators that have variables, you really should take time and write that. So again, just as a matter of fact here, we're going to talk about how do we take the derivative of a term that is coefficient times base to a power. It's going to be coefficient times the power, or the exponent, which there is a times n. We write the base, and then we subtract 1 from the exponent. And what are you making again? You're making a function that tells the slope of a given function. It tells the slope of y. That is what y prime does. Y prime tells the slope of y. So enjoy the video, watch it again. It's a mechanical thing that you can practice. Again, there's a million ways in calculus to take the derivative. This is kind of your first look at how to do the derivative for more complex functions. You will learn more complex methods.